on it this weekend. I will give you at least a week to get it done.
Okay.
Yeah. So no matter, like if I assign it on Tuesday, because I'm gonna hand it out. If I assign it on Tuesday, then it's due the following Tuesday or the following Thursday. Because I want us to get to, I want us to tackle these hard things that made it to where we have this type of distribution. And so I'm gonna pick out questions that we commonly missed here and try to create an activity that has you go through a certain set of questions to start to understand what's happening, that kind of thing. So that'll take me some time to figure it all out. So I'm gonna pass back the quiz and the exam and the homework that we had, so it's all here. Carmelita.
Cheetah? Jessica?
Yeah, it's like I don't know what reasons. Okay. That's all I have for that. Do you guys have any other comments about what I'm planning on doing for us to get, to bring this up essentially, just our basic understanding and knowledge from this first exam? No?
Are we gonna do that whole flick in the classroom thing again?
Interestingly enough, the fluids and electrolytes, that was a hard chapter in general. So it's hard to tease apart if flipping the classroom was a result of that, because the genetics is the best part of this exam. But again, the genetics was something you've seen in 1410. But the fluid and electrolyte was stuff that you did in A&P 1, the skeletal muscle, which was already a hard topic to be.
I feel like I probably would have had a better understanding of things if we would have done a lecture instead of in-class activity, because that in-class activity, I felt like I studied, and read the chapter ahead of time, but I still didn't fully understand the information. Does that make sense?
Yeah, I actually, because I did a few things. Now that we're on this, I'll tell you my thought process here. So for the first thing, cellular energy, I keep on calling it energy, but injury, I did those boring lectures. I was boring myself. Anywho, I was like, I can't do this anymore. It's so bad. So I flipped it. And I was like, okay, I'm gonna see how well we do in these different sections. And then the neoplasia one, I did more of, I'm just gonna hit difficult things in this one. I'm not gonna be as structured with it. And the worst was the fluid electrolyte. The best was the genetics. Those are the ones I flipped. The second worst was the neoplasia. And the second best was my boring, bland, cellular injury lectures. And I would love to say I want to go back to the boring, bland, cellular injury lectures, but we'll see. Like today, it's going to be kind of like that, but I have a little case study that I'm going to give you after I talk about those things, hopefully. So I'll have gone over the material a little bit, and then I'm going to have you do an activity, just like you suggested. Okay? We'll see how that goes. Other comments? All right. Yeah, and then after we do this 5-point activity, and we do awesome on it, I'll put a different spread up here, and we can be all happy instead of sad.
Can you make it a 10-point activity?
What?
Can you make it a 10-point activity?
No, that's ridiculous. I'm like, no, I'm not doing that. And I forgot my water. I will be back in a jiff. I want to get my water, okay? Because that's not going to work for me.
The clock's out, which is 60 minutes. She's fucking nuts. Like, well, her notes are all over the place.
Yeah,
She doesn't go off the PowerPoints.
She says you're not, it's not about hypoxia, and the PowerPoint says it's hypoxia, so
Yeah.
she's nuts. She's your
Well, and she grades like hard ass.
Yeah,
Makes
it's like
it
her answer
impossible.
or it's wrong.
Right. She's had to study to teach it.
I know, but that's what I'm saying. How come you don't know the material? You're supposed to teach us and you don't know.
I don't know if I want to say. I have a stone.
Why don't we all just seriously?
I don't know how she's.
Is the 69% average typical in a Pathway 1 class?
I think the 69% average is actually good in a Pathway class.
Really?
Yeah. For the first exam. It's actually a good thing, but it's not good for me. I like to get into the 70%. Patho's a hard class, and it's a tremendous amount of information. And I think that students struggle because they forgot the stuff that they had learned in prior classes. And I think to some extent, they don't think that they need to go back and relearn it. And I think by the second exam, fingers crossed, we're starting to say, okay, I forget this, I'm gonna go back and look at it. Or it might be such new material, because we're doing immunity, and I always thought that microbiology did a lot of that, but I have been talking to people, and it sounds like the stuff we do in Patho is very different. So we'll just see how it goes. Other questions?
Are we gonna go over the test at all?
No. The way I do it is I want you to look at the ones you missed and,
Well, I did that. There was just a couple that I didn't know, like they were worded weird, so I didn't know really how to look it up.
okay, which one?
I don't know, maybe it was just worded weird to me. It says, what is the most correct regarding normal electrolyte composition of the body?
Okay, that's dealing with, where do you have more potassium? Is it inside or outside the cell?
Outside the cell.
Potassium?
Oh,
K positive? It's inside the cell. Where do you have more sodium? Outside the cell. Okay, so it's asking questions like that. And that's referring to the intracellular compartment versus the extracellular compartment. It's on that particular slide. Other quick questions? Okay. There, in this PowerPoint slide, there's a list of terms that you want to be familiar with when we're talking about infectious diseases. An infection is going to be where you have a pathogen that is going to invade an organism and cause damage to that organism. So an infectious disease is one where you've been infected with a pathogen. A disease, so pathogen is one of these terms. And so that's an organism that invades the body, causing disease, a disease state. Okay? In addition, I gotta look at what my list is, because I can't remember all of them right off the top of my head. And so when we're talking, so a lot of this class is gonna be more of like epidemiology with infectious diseases. So, you know, how many people have this infection? How many new cases do we have in this population? And so the first one is called incidence. And an incidence is the number of new cases. Then you're going to have this term called prevalence. I don't know if I'm spelling it right. This is going to be the number of active cases. And then you have this term that's called endemic. And endemic just means that the incidence and the prevalence are stable within a population. So when I'm talking about these things, number of new cases, number of active cases, I'm talking about within populations. And it specifically, we're talking about the human population. So New Mexico has its own population. Colorado has its own population. The whole continental US, that's a population versus a population in Canada versus Mexico. And so the endemic means that these things are stable. So a stable incidence and prevalence. This is just saying, have you ever heard of endemic species? Have you ever heard that term? That means that that species is supposed to be there, type of thing. It's not like it's a species that came from the Mediterranean, like Russian thistle. Instead, it's actually the cottonwood that's always there. And when we're talking about stable, it means that there's always a certain number of active cases at any given time in the year. And then as those infections resolve, you have a stable amount of people that are getting that same infection. Okay? So let's say your population is 10, And on average throughout the year, 3 people have an infectious disease. But as one person is getting over that infectious disease, one person is getting that infectious disease. So that's what we mean by endemic. Everybody good with that? Now, the other 2 terms that you need to know is epidemic. This is where you actually are going to get an increase in the incidences that are occurring. So we're going to talk about agents of infection. And we got bacteria. We have viruses. We have parasites. And fungus can also be a thing that causes an infection. That's what I mean by agent, causes an infection. Oops. Now, in 1993, in the Four Corners region, Navajo people were getting a disease that looked like the flu, but they were actually dying from it. 50, just in one period of time, in 1993, 50 people got this mysterious illness. They originally thought it had something to do with just Navajo people until a Scandinavian was visiting the area and got the same thing. And a huge percentage of them ended up dying, and they couldn't figure out what it was. But this was an epidemic because it went from nobody having this to 50 people having it. Those are 50 new cases in that year. The disease I'm talking about, do you know what it is? Hantavirus is the disease that I'm talking about. They finally figured out it was similar to a disease that Korean soldiers had that was attacking the kidneys instead. This one in particular was attacking the lungs. All right? The other one you need to know here is a pandemic. A pandemic is where the infectious individuals that have the infectious disease, it essentially crosses continental borders.
What was the disease for the epidemic?
Hantavirus.
So a pandemic would be an example of maybe Zika virus. Would that be considered a pandemic?
Yes, that would be considered a pandemic. Also
Flu, SARS.
right, and then the what is it? The bird flu one. What is that one called? The avian flu. That one. Yeah, it was in China, and then we started it. I think some of it was happening here in different areas. Yeah, I mean, for example, it would be called a pandemic if we had something that was in the U.S., but if it then went into the population of Canada, they would call it a pandemic because it crossed. Or no, I should say because we have North America and South America. So I should say if it went into that South American continent.
So a pandemic would be like something that crosses a continental border as opposed to an endemic or epidemic, which would be within that same, like within the United States, but an endemic would be within that state or a certain area in that state.
Endemic means it's always around. Like the flu is always around. The common cold is always around. The only time that we would bump it into epidemic is if we got a huge increase of the flu and people are dying and an epidemic is where you get an increase in incidence. Now everybody, and this has variation. There's a range in here. Obviously, some years people might get more flu than other years. But whenever it starts to cross continents, that's when they get concerned because if it's in this one area and now it's going to this other continent, there is a huge chance that it could become a global problem. And so in those situations, they want to really study it and figure out what is going on so they can try to treat it. And that's what was going on with the hantavirus. They didn't know what was happening, so they didn't know how to treat it, or even if it was even possible to treat it, or even to tell the public what they had to do to avoid getting it. Other questions? Now, the other terms, I'm going to write over here. Is colonization. And colonization is just, it's usually applied to just normal flora that inhabits an area, and we usually are thinking of host here. But we're going to see that the reservoir for these agents isn't just a living thing. They can be in the soil as well. They can be in the water, all right? But colonization of this is where they find a suitable habitat to thrive and to form a population. Now, when we're talking about it in regards to having a living host, you can have what's called a residential flora. These guys are always there. And they don't do any harm to you. And in particular, in a lot of cases, they have a symbiotic relationship.
What is the difference in that and the colonization?
The difference in this one versus this one is that they're always going to be there. This is a more general term, colonization. Residential flora is going to be one that is always there, like Escherichia coli in our gut. Some people might just say that there's no symbiotic relationship, but Escherichia coli is going to help break down some of the stuff that you can't break down. And it's actually near the end of your small intestines, that colonization. And so the stuff it's breaking down, when that gets into the large intestines, you absorb some of it. And so I view that as a symbiotic relationship, personally. But in regards to colonization, that's just an organism setting up shop. And in particular, that organism that's colonized an area might go away. And so you have this thing called transient flora. Transient flora is, it colonizes, and then it leaves, or it's the residential flora that's there, well, I'll compete and get rid of it. Now, the transient flora usually happens when you're on antibiotics. This is a common thing that'll happen with antibiotics. So, what'll happen with antibiotics is that they just kill everything. And they end up killing the stuff that's there normally and opening up for other species to colonize. However, once you're off the antibiotics, these guys bounce back quickly and reclaim and outcompete these. And then those are out of that particular environment within your body. All right? I mean, you have bacteria on your skin, in your gut. Yeah, Staphylococcus is very prominent on your skin and in your oral cavity. And then the last thing is opportunistic. Now, this residential flora, in a sense, it'll maintain its population. But if a situation changes where it thinks that it's able to increase its size and that it's gonna benefit from that, it will. When that does happen, and that's, food poisoning's a big example, like you already have Escherichia coli, but then you add more of it, well, Escherichia coli from that contaminated food, and then it's just, I kinda like view it as like, all right, we have more numbers. So we are just taking over this land.
So the balance between those resident flora that are within there are unbalanced now, right?
When it becomes opportunistic.
Yes.
Yes, and then that can lead to disease. Okay? Are there any other questions about these things? All right, so when we're thinking about infectious diseases, there's actually a chain that happens with them. I'm gonna use my red one because it's my best one.
The first in this chain is the reservoir. So the reservoir can be an animal, it could be an insect, it could be soil. But this is where that agent is colonized, all right?
Can I ask you a question real quick?
Yeah.
For the opportunistic, the slideshow says it's flora gone wild when the host immune system is compromised. But you use resident flora eating out of can.
That's a lot of times when that'll happen, actually.
it's
So
not
when your
just-
immune system is compromised, that's one way it can happen. But a lot of times this residential flora, part of why it's kept in check to some extent is the immune system, making sure it doesn't explode. An example I'll give you an example of this. People who use corticosteroids for asthma, they will spray that in their mouth. If they don't swish it out, what'll happen is that corticosteroid actually suppresses the immune system within your oral cavity, and you have a yeast called candidiasis.
Candidus,
Candidus.
albicans.
That's already there, but you suppressed your immune system, and that residential flora takes advantage.
But wouldn't that
And then you
be
get
more
thrush.
transient?
No, it's always there.
Same
You
thing with
have
hand, foot,
in your
and
mouth right now, I can't say it,
Candidus albicans.
Candidus albicans. But the thing is, it's kept in check by
Is that the
the
same
immune
thing
system.
as like when a little kid gets hand, foot, and mouth?
I'm not familiar with that.
It's-
That's a virus.
Yeah, that's a virus.
I'm
But
not
they still
familiar
get
with that
thrush
particular.
on the tongue.
Thrush is a yeast.
Oh.
And did you say it? Well, say it again.
Candidus albicans.
Candidus it's already in there. It's in your mouth right now. But then you lower that immune system, those corticosteroids block the immune system from keeping it in check. And then that yeast multiplies, and then you get thrush. I don't know if any of you are familiar, but it's this yellow film thing that's on your tongue and the sides of your cheek. It's so disgusting.
Babies get it.
Mhm.
Yeah, so it's already there.
Well, the disease that I'm asking about is called herpingiana, hand, foot, and mouth,
Mhm.
and similar symptoms, so that's why.
A lot of things have similar symptoms because it's based on the immune response is the thing. Typically, because so many things have similar symptoms, they do blood tests to figure out, to try to see what's really going on. And then with your question, the transient flora, in regards to the immune suppression, it might be something that wouldn't even set up shop because the residential flora says, it's out competing it, okay? But then the immune system's suppressed and starts actually making more sites available for colonization, and those transient flora will take advantage of it. And in a sense, they're becoming opportunistic as well.
So sometimes you give us like different examples on the board than what's in the PowerPoint, is it better for us to write down your examples on the board or to study what's in the PowerPoint? 'Cause that's-
Study what's in the PowerPoint,
Okay.
yeah.
That's kind of confusing though.
Know what's in the PowerPoint. The examples that I give you in class is intended for you to understand it better.
Okay.
And in regards to a quiz, when I ask you to give an example, then it's fair game.
Okay. you can
Either
do that.
one, yeah. So here's your reservoir,
And then you're gonna have the next chain, so these are like linked together, is portal of exit. And when we're thinking of portal of exit, we're really talking about this agent moving from this reservoir and outside of it. And if we're talking about an animal, it could be in regards to the digestive tract could be a portal of exit. Respiratory tract could be a portal of exit. All the tracts, really. Urinary, but not so much. Reproductive tract could be a portal of exit.
So like laying eggs.
I'm really thinking of sexually transmitted
Okay.
disease.
So for the.
So then the thing here, here would be through in feces. It's at the portal of exit is the digestive tract, and then we have feces. Here, we would have mucus or mucus droplets such as cough.
Are those three all for animal?
Yeah.
Okay.
Reproductive would be semen.
Okay.
And then we go into what's called mode of transmission. And the mode of transmission, the way we can think about this is the way that it's going to
Go from the reservoir to the host.
And so you can have it be penetration. You could have it be inhalation. It could be ingestion. Or it could be direct contact. And you could also have indirect contact. This is a new one that's not in the PowerPoint.
But penetration would be like stepping on a nail, okay? And then you get an infection from that rusty nail, all right? Or a cut that you get. You've broken the surface here, and now that thing can penetrate in. So this is usually from some type of damage to the skin or
So
a
like
bear.
a bite from like a mosquito or a dog.
Yes, that would be penetration, exactly. Inhalation, so, the flu, everybody's caught it. It's actually, I think hantavirus is another one. This is a much better one. So hantavirus, what happens is the reservoir is rodents in the community. The rodents in their feces and urine contains the hantavirus. And then once that feces and urine dries up, it becomes an aerosol. So now, for hantavirus, the reservoir is a rodent, the portal of exit is the digestive tract and the urinary tract. The mode of transmission is going to be inhalation, okay? Ingestion, that would be food poisoning.
Isn't the mode of transmission the insect bite or the nasal?
The insect bite is penetration. So the insect bite is an example of penetration.
But it's
But that's
inside
if
the
it's
mode
on
of
portal of
transmission.
entry. Skin
Then,
puncture.
and then skin is the portal of entry, or it's gonna go directly into the blood, okay?
when we think of mode of transmission and portal of entry, they're very paired with one another, okay? So then, portal of entry, that is going to be, you can have that happen in the respiratory, it could be digestive tract. You could have it be this direct contact with skin. All right, these are gonna pair up like this. And penetration goes with skin as well, actually. Think of the portal of entry as on that host, because we're really talking about a host now that is going to get this infectious disease. Where on their body did they get this infectious disease? Did they get it through the respiratory tract? Did they get it through the digestive tract? Did they just get it in direct contact with another person? Because it can go like I could touch somebody's skin, they could have it on their skin because they have a wound or something, and I could get it that way. I mean, typically that's not as common. Usually what will happen is you touch their skin, and they don't wash your hands, you go to your mouth, and now really the portal of entry is ingestion, okay? And then finally, like once it gets in you, you're the victim now, all right? And so, I don't know how to spell this word, susceptibility. So you're a victim, but how susceptible are you? And with this, it's going to be, how healthy are you? Meaning, do you have are you getting all the nutrients that you need? So, are you malnourished? It's really what this one's about. Getting enough sleep, just being a healthy person is going to decrease you being susceptible to this agent that has gone into your body. The other thing is immunization. So they have a lot of vaccines out, and if you haven't gotten those immunization shots, you're more susceptible. And you can break this chain and stop the progression of this infectious disease here, all right? For the reservoir, you're gonna want to eradicate, okay? Or you're gonna want to put in place something that manages it, such as garbage disposal.
So the reservoir is where it's getting destroyed?
This, I'm breaking the chain. This is destroying it.
Okay.
So here you destroy it, but essentially you don't even start this thing. So for example, we actually did have malaria here in the US at one point in time. They went around with that DDT and killed all of the mosquitoes. They eradicated that disease in the US because they killed the mosquito, which was with the reservoir. That's how they did it. The Black Plague, way back when, was a consequence of not having any kind of sewage treatment. And an increase in the human population, and so they don't know where to put their crap, literally. And so having all this crap around, you're gonna start to see more disease because you're creating an environment for these agents to colonize and flourish and to eventually infect a victim, okay? But to stop it at its source, you want to find a way to destroy this reservoir. And you stop it here. Now, in regards to portal of exit and portal of entry, they're the same thing essentially, right?
Except for that one's coming from the animal or insect or whatever, and one is being you, the host.
Right. And hey, somebody else could be the host, right? So, like if you work in a hospital, all those people in there, if they have an infectious disease, they're the host, right? And you could get, if you can transmit it from human to human. Not all diseases are like that, like hantaviruses. But you're gonna have the same way of breaking these. So what would you do to prevent getting an infection from someone if you're working in a hospital? Gloves. Gloves. So breaking. Chain. Break and chain. Gloves. Masks. Gowns. Stuff like this. Condoms, yes. Now there is one that they put down. Put gowns over here. They're the same, okay? Everything is the same except for one thing here that they will do to block this portal exit. And they might isolate that person who is the host or who is the reservoir, okay? So they might isolate them. There was this woman, Mary Malone, that they suspected was the reservoir for typhoid fever. They eventually isolated her for the remaining years of her life because they didn't understand typhoid fever. So she was by herself her last days of life. They essentially arrested her and put her in jail. They isolated her. Yeah, she should have washed her hands, damn it. Exactly. Which gets us to breaking the mode of transmission. Washing your hands. That's what's going to break this here. All right? So, washing hands. Being sanitary, essentially, is what this is all about. A sterilized technique. This is like if you're someone that's having to take the blood of from a reservoir or a hose, you want to make sure you're doing a technique that you yourself don't get infected. And then the susceptible victim is, vaccines, doing vaccines, staying healthy, stuff like that. And so this is just a chain. These are ways to break the chain. Now, once you get an infectious disease, there is actually stages that occur once you get this infectious disease. And so the first stage, it's actually a period. They call this the incubation period. I'm gonna write these all out first. So you have the incubation period, and then you're gonna have what's called the prodromal stage. Followed by an acute stage. Followed by what's called the convalescent stage. And then the last one is resolution. So in the incubation period, there's no symptoms here. Instead, what's happening is colonization of the agent, okay? So it's made its way to here, portal of entry. And now the question is, what happens next, right? It's in you. So it's gonna colonize in there, potentially. Unless your immune system blocks it, all right? The prodromal stage is where you start to see symptoms. And this, typically when you start to see symptoms, okay, you have this agent that has, this pathogen that has invaded your body. Prodromal stage, these symptoms, or because your immune system is trying to get rid of it, okay? And so you start to see symptoms, such as a fever, all right?
So then like the inflammatory process starts to happen.
Yeah. And so in the prodromal stage is where you start to see symptoms because your immune system is trying to get rid of that infection. The acute stage is going to be where the symptoms themselves are at their maximum. So, you know, when you don't feel good, like this one, you might feel like kind of achy and tired and then all of a sudden you just have diarrhea after diarrhea and you just feel really crappy. Okay, like the stomach. And then you start to feel a little bit better. And at the convalescent stage is where you're starting to eradicate, but the agent itself has decreased its population within you. It's still there. Here, wait. It's in low numbers. In this situation, the immune system's done its job. It's on it. You're getting rid of it. You're fighting it. And then at resolution, agent is completely gone. There are people that won't go through this. They'll only get colonization of an agent, essentially. They won't even have any symptoms. That's what's called a subclinical illness. And a lot of times, those will just be completely resolved and you don't even know that you've been infected with a virus, type of thing. And when that happens, you're really, to some extent, this went all the way, but here, you just didn't get sick from that agent. You can have carriers, though, that will never show symptoms at all, but they will still have that agent in their body. And they're called carriers because they can transmit that agent to other victims.
So like HPV?
Yes, like herpes. Exactly. Herpes is an example of people who are carriers that don't have any of the symptoms. They have herpes, but they can give it to other people that can.
And then what he's talking about is like human papilloma.
Oh.
Yeah.
Yeah, so that men are carriers, but women
Women are the ones who see
Oh.
this.
and
Is
sometimes
that a
they
sexually
don't.
transmitted disease?
Yeah.
Oh.
Yeah,
Oh, yeast infections is the same thing.
Guys can see yeast infections, can't they?
Well, see, what ends up happening is that men will have a yeast infection.
or they'll take antibiotics.
Yeah, and then they'll have sex with a female, and the inside of the female's reproductive system is a happy place for that yeast, and it'll just colonize in there. And so that's like a similar thing, you know? But we have like yeast all over our bodies. It's just, you know, it's like, give us sugar. You have sugar everywhere, we want it.
Any other questions? No?